Hey guys, it's Miss Johnson and I'm here to bring you our notes for section 9.2. We're going to split this section into two parts again, and today we're going to actually carry out a test of significance for a population proportion. So let's just review the conditions that we need. The conditions that we need are very, very similar to the conditions we needed for the confidence interval. We need to state that the data came from, or that our sample was a random selection. We need to also show the 10% condition, that our sample is less than 10% of the population, because that's assuming that we're not replacing our subjects. And then we also do the large counts. In large counts, we're going to take the n times the proportion, and then we're going to take n times 1 minus the proportion, and they both have to be at least 10. So those three should look really similar to what we would do in confidence intervals. Okay. For the test, we use the null p-value, which is why it's called p sub 0. Okay. So we want to be careful that we are not using p hat. We don't want to use p hat for this. We want to use the null proportion. All right, so let's just talk about checking the conditions. So this is an example. It says, according to the U.S. Census Bureau, the proportion of students in a high school who have a part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than that figure. She would like to carry out a test at the alpha 0.05 level. Here's her hypotheses. Okay, so she stated her significance level, she stated her hypotheses, and then she stated what P is, where P is the true proportion of all students at the high school who have a part-time job. Okay, this, by the way, would be the state portion of your whole test. Okay, so they did the statement for you here, and now you're gonna do mostly the plan part, where you are going to check the conditions. So it says, if the administrator selects a random sample of 200 students and finds that 39 of them have a part-time job, and then it says check the conditions for performing a significance test. Okay, so our first condition is that we need to say that it's random. And so right here it says the administrator selects a random sample of 200 students. So randomness is applied. Okay, so that one's good. Then the next one is the 10% condition. Now, in this example, if you looked at this example in the book, this word is actually the word large. So for some reason in the notes, they say local, but we're told that this is a large high school. So it is safe for us to assume that 200 students is less than 10% of a large high school. Student body. And then the last one, so that one's good. The last one is the large counts. So large counts, we need to make sure that our n times p, so our p sub 0, or our null p, is the 0.25, and that's the one that we want to use. The n is 200, so n times p sub 0 is equal to 200 times 0.25, which in this case is 50. 50 is greater than or equal to 10, so check. And then n times 1 minus p sub 0 is going to be 200 times 0.75, which is 150, which again is greater than or equal to 10. Check. So our conditions are all met for this example. This, by the way, would be most of your do step, aside from stating the test. Okay, so when we get to the point that we are going to perform a significance test for P, we then need to start talking about the shape and the variability of it and how we would find the standard deviation so that we can find a probability, a p-value. So This is just an example. It says a basketball player claims to be an 80% free throw shooter. You think the player is exaggerating. So here's your null and your alternative. I apologize, they had the wrong value there. So cross that value out if you're looking at a blank template of the notes. So 0.8 and P is less than 0.8. So if the null is true, then what values of P hat should we expect in a random sample of 50 shots? Well, let's talk about what we know. If we describe this distribution, we know that because the large counts condition is met, that the sampling distribution will be approximately normal, okay? That's just a thing we know about using the large counts condition with sampling distributions, okay? We also know that we can take the mean of P hat, the mean of our sampling distribution is going to be the same as our proportion, which is 0.8. So for our center, we've got a mean. Then because it's normal, I can use that sampling distribution standard deviation that looks like this and get a standard deviation of 0.566, okay? So those are all the things that I can assume to be true so that I can find a p-value for my significance test. So now that I know all of those, here's that wrong value. You can cross that out if you see it, but it's 0.8. I just have it, the wrong value in that box. So then what I want to know is if the player makes 32 out of 50 shots, my p-hat value is 0.64, then what z-score is associated with that? So you do 0.64 minus 0.8, or this is another place where you can do normal CDF, which is what most of you choose to do, is type it into your calculator. Your lower bound would be negative infinity because we're talking about the left end of the curve. So you'd be at negative infinity, and then you'd come up to the 0.64, and then you'd have a mean of 0.8 and that standard deviation of the 0.0566. But when you do the z-score, that gives you a test statistic of negative 2.83. Okay, so negative 2.83 is my z-score there. So the test statistic is the same as finding a z-score. You do the statistic minus the parameter divided by the standard deviation. And again, some people use technology. So if you were using technology, you'd use your normal CDF. And this is a negative 2.83. So you'd go down to negative infinity or negative 1,000 or whatever it may be, and you'd go up to, your upper bound would be negative 2.83, your mean is 0, your standard deviation is 1, and your p-value then is that, 0.0023. So this is your p-value for your significance test. Instead of finding an interval like we did in confidence intervals, we're finding a p-value that we want to test against our alpha value. Okay, so let's talk about another example. In the preceding example, the administrator at the large high school decided to perform a test at the alpha value of 0.05. Here were the hypotheses. You know, your null was the proportion equals 0.25, and the alternative was the proportion is less than 0.25, where P is the true proportion of all students at the high school who have a part-time job. So that's your definition of the parameter. It says the administrator selects a random sample of 200 students, so we're still looking at that. 39 of them have a part-time job. We've already confirmed that conditions are met, so those are good, check. So then in part A, it says explain why the sample result gives some evidence for the alternative hypothesis. Well, if I look at my p-hat value, so this is part A, my p-hat value is 39 out of 200. 39 out of 200 is less than 0.25. So I get 0.195 there when I plug it in. Go ahead and type that into your calculator if you have it. So 39 out of the 200 is 0.195. And since 0.195 is less than 0.25, we have some evidence that the alternative could be true. Then it says calculate the standardized test statistic and the p-value. So this would be in our whole statement. This is like your do step, okay? So the standardized test statistic looks like this. I would do a z of 0.195. It's always data minus mean over standard deviation. In the standard deviation, I have the 0.25 times 1 minus 0.25, oops, 25. And some people calculate that piece separately. You certainly can if you'd like. Pull that out and do that on its own. But that's what my standard deviation would look like in the denominator because it's a standard deviation of a proportion sampling distribution. So I'm going to take care of that denominator, 0.25 times the 1 minus 0.25. And then I'm going to divide that by 200, and then I'm going to take the square root of that. Okay, so there's my denominator. So then I'm going to take 0.195 minus 0.25, and I have negative 0.055 there. So I'm basically just typing that whole thing in red into my calculator. And I end up with a z-score of negative 1.796, roughly. Okay, negative 1.796 is approximately my test statistic. Okay. Now, the test statistic is what I'm going to find the probability of. So here's where I'm going to go to normal CDF. Now I go to normal CDF, and I type in all those things. My lower bound, because my alternative is that it's underneath. So I want to test from down below, so like negative infinity, up to my test statistic, which is the negative 1.796, because that's the statistic that I got from doing all of this with my data. And then my mean is now 0, and my standard deviation is now 1, and plug all that in. So I've got second distribution, go to normal CDF. I need negative infinity. I just like to type negative 1 and then a whole bunch of zeros. That's enough. Negative 1.796. Mean is 0, standard deviation is 1. I get 0.036 there. So my p-value equals 0.036. Okay, there's my p-value. So that's part B. And then the question becomes, what can we make of this? What's our conclusion? Okay, so I'm going to come over to this slide where I have a little bit of room, but I'm just looking at part C here. What's the conclusion that I can make? So this would be like your conclude step. And your conclude step for these should have 2 sentences. The first, so let's look at it against our alpha value. So here's my little measuring stick. I've got an alpha value of 0.05. My p-value was the 0.036, okay? So this is where we are going. This is below the alpha value, which means I'm going to reject the null. So in my conclude statement, I would say because our p-value of 0.036 is less than alpha, which is 0.05, we reject the null. And I always put what that null hypothesis is. It's just good to state it. And then you're set. So that's sentence number 1. Then this is always a 2-sentence conclusion. The sentence number 2 says we have convincing evidence that the true proportion of students, because now we got to put it in context. So the true proportion of students who have a part-time job at this high school is less than 0.25. So one sentence stating the data, second sentence stating the conclusion. All right, so here's our 4 steps. State plan, do, conclude. So now let's go through and actually put them all together. We've already talked about the random condition, the large counts conditions, and the 10% condition. These are the same things as in significance tests, or in confidence intervals. So I'm not going to spend a whole lot of time on those. They are still something that is necessary. They are still needed in significance tests. So these three things are part of your plan statement. Okay. This is your test statistic equation. So this is how you get your z-score that you would then plug into normal CDF to get your p-value. So you always take p hat minus p, and then you put that standard deviation of the proportion in the denominator. Okay, so now we have to be a little bit careful here because we've got a one sample z-test, but sometimes we're looking at the greater than side. Sometimes we're looking at the less than side. Sometimes we're looking at where it's not equal to. And this is what we call a two-sided test. We're going to get into how to calculate a two-sided test in a second. But you just have to watch your inequality symbols. Are you looking at less than or are you looking at greater than? Because that's going to depend on how you type it into normal CDF in your calculator. So that depends on your, that's going to change your upper bound and your lower bound. All right, so here we go. Recall that a potato chip producer we met in section 9.1 and its main supplier agree that each shipment of potatoes must meet certain quality standards. If producer finds convincing evidence that more than 8% of the potatoes in a shipment have blemishes, the truck will be sent away. We talked about this when we were looking at the type 1 error and type 2 errors back in section 9.1. Same example, so it says, supervisor selects a random sample of 500 potatoes from the truck. The inspection reveals that 47 potatoes have blemishes. Is there convincing evidence at the alpha 0.1 level that more than 8% of the potatoes in the shipment have blemishes? Okay. Anytime you're given an alpha level and anytime they ask about the convincing evidence, especially like if you're given an alpha level, that tells you you're doing significance test. Okay. So let's go through it. Now we're going to go through our 4 steps: state, plan, do, and conclude. So the first one, state. Okay. We want to test. And then state what your hypotheses are. So your null is that p is equal to 0.08. Your alternative is that p is greater than 0.08 because they said, is there convincing evidence at the alpha 0.1 level that more than 8% of the potatoes have blemishes? Okay, so there's my hypotheses, but then I also have to state the parameter. So where p is the true proportion of potatoes with blemishes on this truck. Okay. Oh, and oops, I almost forgot. We want to state this at the alpha, we have to state our alpha value at 0.10, at alpha equals 0.10. So you have to state your alpha value first as well. It's important to state your alpha value before you do the test because otherwise it's not authentic. If you do the test and then you pick an alpha value after, you're kind of controlling the results. So it's really important to state your alpha value before. Okay, so let's do the plan part. So plan. So my plan here, I have to state the test. I'm going to do a 1 sample z test for p. Instead of a 1 sample z interval for p, I'm doing a 1 sample z test for p. Now check your conditions. So random, finish the word there, random. So we have a random sample of 500 potatoes. 10%, n equaling 500 is less than 0.1 of capital N potatoes on the truck. It is definitely safe to say that 500 is less than 10% of the potatoes on the truck. And then large counts. So here's where we have n times p. And remember, you're always using the p sub 0 value. You're not using your p hat. So we haven't even calculated p hat yet. So that's going to give us our p hat right there. But for our conditions, we want to use the p value. So n times p, so this is 0.08 times 500, which gives me 40, which is greater than or equal to 10. Check. Then I have n times 1 minus p, which is 0.08, or sorry, 1 minus 0.08. 1 minus that times 500, which is going to be the other piece, 460 of them, greater than or equal to 10. Check. All right, there's your plan. So state the test and the parameter. State the hypothesis and the parameter. Plan, name the test, do the conditions. All right, so now let's get into the do part. So for do, I have to actually carry out the test. So first thing, find your p hat value. P hat is going to be 47 out of 500. That's less than 10%. 47 divided by 500, 0.094. Okay. Now do your z, your test statistic. So my test statistic is going to be 0.094 minus 0.08 all over that standard deviation. You've got and this is, you use the proportion value, 0.08 times 1 minus 0.08 divided by the 500. So plug all that into your calculator. 0.08 times 1 minus 0.08, and then divide that by 500 and take the square root. There's my denominator. 0.094 minus 0.08. I'm going to do that divided by that denominator that I found above. I get a test statistic here of 1.154. Okay, so now go in and find your p-value. So p-value, if I use my calculator, I'm on normal CDF. I want a lower bound, because now I'm testing greater than. My alternative, remember that H sub A was that P was greater than 0.08. So I'm looking at the right side. Okay, so my lower bound is the 1.154. My upper bound is the positive infinity. And then my mean is 0, standard deviation is 1, and I get a p-value. Let's plug that all in. So second distribution, go to normal CDF. You've got 1.154 for your lower. Upper is positive infinity. I just do 1 with a whole bunch of zeros. 0 and 1 is my standard mean and standard deviation. I get a p-value of 0.124. Okay, so there's my p-value. Now let's talk about what that means. Our conclude statement. So in my conclude statement, this is the last piece. Think about that little measuring stick. So this time my alpha value was 0.1, okay? Your p-value is up here. P is equal to 0.125, approximately, or 0.124. I think 0.124. So your p-value is above. If your p-value is above, we fail to reject. We never want to say that we accept something, but we're going to say that we fail to reject the null, okay? So we're not accepting the null. We're just failing to reject the null. We just are not, what we looked at is not enough evidence to say that our null is wrong. So here's my 2-sentence conclusion. Because our p-value of 0.124 is greater than the alpha value of 0.1, we fail to reject the null. And then I always put what the null is. H sub O, p is equal to 0.08. Now put it into context. Here, since we're failing to reject, we don't have enough evidence. We do not have convincing evidence to reject the null. And then state what that means. That there is more than 8% of potatoes with blemishes. So even though the sample we pulled had a higher than 8% value of potatoes with blemishes, it wasn't enough to provide convincing evidence that the whole truck needed to be sent away. So that's kind of what this test is showing. All right, AP exam tip here. When a significance test leads to a fail to reject decision, as in the preceding example, be sure to interpret the results as we don't have convincing evidence for the alternative. Saying anything that sounds like you believe HO is true leads to a loss of credit. So you're not saying that you think HO is true, what you just did, the sample you just looked at, did not provide you convincing evidence that the alternative was true. So it would be wrong to conclude there is convincing evidence that the proportion of blemishes is 0.08. You're not saying that. You just don't have enough convincing evidence to say that it's not 0.8. All right, so this last AP exam tip, it says you can use your calculator to carry out the mechanics of a significance test on the AP exam, but there's a risk, and we've talked about this a lot in this class. If you give just a calculator answer with no work, you will definitely not get credit for the do step. They use the word probably, I'm gonna use the word definitely. If you don't show any work and you don't state it in terms of context, like you don't show the Z, you don't show how you got the test statistic, you don't show how you got the p-value. If you don't show any of that, that's going to be a problem. You can't just do normal CDF and call it good, is basically what that is. But you've all heard me say that. You've also all heard me say lots and lots of times you have to label your upper, your lower, your mean, and your standard deviation. You have to have those words in there. Don't just list the values in order. They want to see that you know what those values are. All right, that's the end of our first half, so we'll pick it up with the second half in the next one. Thanks for tuning in.